So this is the 49th word. Okay. And then we're setting, the word is setting when we call it. It sets, remember how it sets? It sets the MA and TH variables, and then it gets them right back on the stack again, so our stack is the same as our variables. And then it does plus, and then it does total store. So it does set and get, and then plus is the stack, does total store, and then it calls show, and then zero, and it falls into notate. Notate calls a blank text, which sets, you remember what we said about setting that, duplicates this zero, so I'm going to use it twice, and then calls this. So now the yellow execution of these four words right here compile the number 822 block 49 plus on compilation of this block. When this block is loaded, the word this is defined in the dictionary, and these four words become a number right and compiled right before, they become a number on the stack and compiled right before this plus. So it's sitting there as a one single number waiting for me to plus in something, and this zero is what I'm going to plus in this time. And then I'll fetch from that address, which is the address of this word sum. I'll detag it, and I'll unpack all the three letters. It'll unpack automatically the three letters until it has no more letters to unpack. It'll drop the extra zero. Okay, and so now I'm going, and so I'll unpack and emit them. There it is. It'll emit them unless it's a zero, because the next time around it'll be a zero, it'll drop it. Okay, so now I'm going to put two carriage returns. I'm going to get my variables, and I'll drop one of them, and then I'll use the hex or decimal printer to decide which type of number to print, a space, and then I'm going to increment, on the stack is still this zero right here, so I'm going to increment it by 2, and then go to this again. So what does that mean? Well, that means I'm going from sum to plus, and I'm going to now print plus in the space between the two words. And I'm going to get those variables again, print the first one and drop the second one. I know, okay. And then I'm going to call our old is word in another space, and this extra space is used for the hexadecimal print. It looks a lot better. And then I'm going to get the grand total, the GT. That's a new word that we haven't shown yet, but there it is. It's GT. So total fetch. And then we're going to, because it's convenient for me and the program, so I use it that way. And then we're going to print that grand total in the keyboard. Keyboard is also stored as 2 words. So that means inside each one of these words is defined, it is the name of the program. It uses itself as the name at the top of the program. A set action has happened, and then the function happens, and then the function name itself is used in infix notation rather than postfix notation. I could have done it either way. And then total store, show, and now we have offset of 32 notate. That be the word prod is 32 away from sum. Let's see, diff is 41 away from sum. And then I put in, you'll see in diff and quo, I put in 2 white words here to take the place of our function words because we're doing something different here. And that was convenient. Okay, so we have 4 words that all do their function before they show, and then they put an offset into a very same word that displays all 4 functions. That way, if I make changes to my displays, I can make changes to this one word, and then so long as I make sure to follow my rule of offset, I won't hurt anything, and I haven't hurt anything, and it's really not that big a deal. It's ridiculous to do this, obviously, to do it by offset. It's just something I can show you, but it does have implications because you'll notice that I'm starting to do things by address and offset. Addresses I always know because I always know my block system, and offsets because well, we can do a couple things with offsets. We can increment through a block until we find a second color or tag or whatever. So these are all ideas that are running around in my head right now that are changing the way I do code, and this is following this sum diff prod quo stuff is the is an example of that. Here we have another set of variables. Now, it turns out in a calculator, it's also convenient to have a couple extra memory variables to save state, and I can set them, and I can get them, extra memory. And then, of course, these other words that you see on here we can talk about in a bit too. These have to do with showing examples of using this as a little simulator where we create our own fourth, swap and rotate and over and minus or back rotate. We can do some things that we see in the in starting fourth, like 4 reverse and 5 reverse and under 2 swap and all that. We can create incrementers, and that's what I've got here. I've got a whole study on incrementers and decrementers here, and also a whole study on beginning a study on if-then-else statements, which I've so far never needed, but I understand there are programmers who like that kind of thing, and we can work on that too. The incrementers and steppers is a really cool project, and it's a project all itself. We'll get into that. But let's use this memory stuff. In this block right here, fetch block dump, you can see I've got some numbers stored. I've got a 2, a 7, a 1, 2, 5, 3, 4, and 5. They're not really readable in the editor. They're readable in dump. What am I doing here? Empty. Oops. Oh, my hand is not in the right spot on the keyboard. Here we go. You see a 7, a 3, a 0, but you don't see all the numbers in the editor. I have another program where you can, and we'll do that later. But what I'm doing here is going to and from memory. We can load this block. I don't know why this word is here. That's an error. Okay, and we can